Welcome to my channel, Worldwide. I don't think people understand the sheer power of tornadoes. Tornadoes, these swirling vortices of wind, are a testament to nature's raw power. They are capable of unleashing incredible destruction in a matter of seconds. With winds that can exceed 300 miles per hour, tornadoes can flatten entire neighborhoods, uproot trees, and hurl debris over great distances. Imagine a force that can rip buildings from their foundations, toss cars like toys, and turn everyday objects into deadly projectiles. The sheer power and unpredictability of tornadoes make them one of the most feared natural disasters. That's the terrifying reality of a tornado. But how do these monsters form? What makes them tick? Understanding the science behind tornadoes is crucial for predicting their occurrence and mitigating their impact. Tornadoes are born from severe thunderstorms where warm, moist air meets cold, dry air. This clash of air masses creates instability in the atmosphere, leading to the formation of powerful updrafts. These updrafts can begin to rotate if wind speeds and directions change with height, a phenomenon known as wind shear. As the rotating updraft, or mesocyclone, intensifies, it can tighten and stretch, eventually forming a tornado. Let's delve into the science behind these awe-inspiring phenomena. Meteorologists use advanced technology and models to study tornado formation, helping to improve warning systems and save lives. Tornadoes are a fascinating and frightening weather phenomenon. Their formation is a complex interplay of atmospheric conditions, and each tornado is unique in its behavior and impact. Understanding their formation and behavior is crucial for predicting their occurrence and mitigating their impact. Communities in tornado-prone areas must stay informed and prepared to respond quickly when a tornado warning is issued. Join me as we unravel the mysteries of these whirling winds. Together, we can appreciate the awe-inspiring power of tornadoes while working to minimize their devastating effects. Not all thunderstorms give birth to tornadoes. In fact, only a small fraction of thunderstorms have the potential to produce these violent and destructive phenomena. The genesis of a tornado often lies within a special breed of storm known as a supercell thunderstorm. These storms are unique in their structure and behavior, making them particularly potent. Picture a thunderstorm on steroids. Supercells are the most severe type of thunderstorm, capable of producing large hail, damaging winds, and of course, tornadoes. Supercells are characterized by a rotating updraft, a column of rising air that acts like the storm's engine. This rotating updraft is known as a mesocyclone. This rotation is key to tornado formation. Without it, the storm lacks the necessary dynamics to produce a tornado. As warm, moist air near the ground is drawn into the supercell's updraft, it begins to rise and cool. This process is crucial for the development of the storm's structure. Condensation occurs, forming thunderclouds and releasing even more heat, further fueling the updraft. This release of latent heat is a critical component in maintaining the storm's intensity. This creates a powerful rotating column of air within the storm. The stronger the updraft, the more intense the rotation. Under the right conditions, this rotating column can be stretched vertically, forming a funnel cloud that descends from the storm cloud. This funnel cloud is the precursor to a tornado. When this funnel touches the ground, a tornado is born. The connection between the cloud and the ground is what transforms the funnel cloud into a full-fledged tornado, capable of causing significant damage. In the United States, there's a region that's practically synonymous with tornadoes, Tornado Alley. This area, encompassing parts of Texas, Oklahoma, Kansas, and Nebraska, has a unique combination of ingredients that makes it a breeding ground for these swirling storms. Tornado Alley sits at a meteorological crossroads. Warm, moist air from the Gulf of Mexico collides with dry, cool air sweeping down from the Rocky Mountains. This clash of air masses creates instability in the atmosphere. Add to that the presence of strong upper-level winds, and you have the perfect recipe for supercell thunderstorms and consequently tornadoes. Section 4. Measuring the fury, the enhanced Fujita scale. Tornadoes are not created equal. Some are relatively weak, while others possess the power to level entire towns. To classify these storms based on their intensity, we use the enhanced Fujita scale, or EF scale for short. The EF scale ranges from EF0 to EF5. with EF5 being the most intense. An EF0 tornado might damage trees and rip shingles off roofs, while an EF5 can sweep well-built homes completely off their foundations. The scale is based on the damage caused by the tornado, as wind speeds are difficult to measure directly during these fleeting events. Section 5. Devastation in the wind's wake. The 1999 Oklahoma City tornado. The destructive power of tornadoes is tragically evident in the aftermath they leave behind. On May 3, 1999, an EF5 tornado tore through Oklahoma City, leaving a path of devastation over 35 miles long. This monster storm, with winds exceeding 300 miles per hour, was one of the most powerful tornadoes ever recorded. It killed 36 people, injured hundreds more, and caused over $1 billion in damage. The Oklahoma City tornado serves as a stark reminder of the immense power of these storms and the importance of early warning systems. Section 6. Tornadoes versus tropical cyclones, a storm of different names. In this section, we will explore the fascinating differences between these two powerful natural phenomena. Tornadoes and tropical cyclones, like hurricanes and typhoons, are often grouped together as storms, but they are distinct phenomena with different characteristics. While both can cause significant damage, their formation, structure, and impact vary greatly. The most obvious difference lies in their size and duration. Tornadoes are much smaller in scale compared to the vast expanse of tropical cyclones. Tornadoes are relatively small and short-lived, typically lasting only a few minutes to an hour. They can form and dissipate so quickly that sometimes they are gone before people even realize they were there. Tropical cyclones, on the other hand, are massive storms that can span hundreds of miles and persist for days or even weeks. Their sheer size and longevity make them some of the most powerful and destructive weather systems on Earth. Another key difference is their formation. Tornadoes and tropical cyclones originate in very different environments and under different conditions. Tornadoes arise from thunderstorms over land, often in areas where warm, moist air meets cool, dry air. In contrast, tropical cyclones form over warm ocean waters, where the heat and moisture provide the energy needed to fuel these massive storms. Tropical cyclones are fueled by the heat energy released when water vapor condenses, creating a powerful engine that drives the storm. Tornadoes, however, derive their energy from the interaction of different air masses, creating a spinning vortex that can cause immense localized damage. Section 7. Predicting the unpredictable, the challenge of tornado forecasting. Predicting tornadoes is notoriously difficult. Their formation is often rapid and localized, making it challenging to issue timely warnings. While meteorologists can identify conditions favorable for tornadoes, pinpointing exactly where and when a tornado will touch down remains a significant challenge. Advancements in technology such as Doppler radar and sophisticated computer models have significantly improved our ability to detect and track tornadoes. However, there's still work to be done. The average warning time for a tornado is only about 13 minutes. That's why it's crucial to have a plan in place and to heed tornado warnings.